Hello all and welcome to your last video for the AP test in this class. Now, as we get more and more details about how AP testing is going to be held this year, I will let you know as soon as I have any details. But as of recording on March 10th, what I am planning on is that we are going to aim for that first test date and see what happens over the coming weeks. So you have a little bit of work here. It's something that's sort of different and separate. You can take a big breath from series before we dive back into starting to review for things after spring break. So hopefully this will feel like a nice review, breath of fresh air as we talk about vectors. So get yourself ready for notes and we're going to get started. Now, as you would hopefully remember from either your physics classes or maybe even your pre-calc class with me that many of you took, a vector is a mathematical object. So like a variable is also a mathematical object. And what makes a vector special is that it has both magnitude, so it has a scale, length, force, and it has direction. So it shows up a lot in physics, like I said, as a force. So what a vector will look like is something like, in here, it says find the vector -4, 3. So what that means is that if I start at a given point in space, -4 is the x horizontal component. So you can think of this as almost like a point on the coordinate plane. So horizontal component is -4, and the vertical component in this case is 3. And that's going up because it's positive. So the vector itself is this, that just automatically did that there, is this blue line here with, we might call this U, and it is the vector -4, 3. You might also see this written as -4 with a bold I for the horizontal component and 3J for the vertical component. Now the magnitude, as I said, means its length. So whenever we're working in a case like this, you'll notice I've drawn a right triangle here. It is -4, 3. The magnitude is going to be with the Pythagorean theorem. We write it like the absolute value. So that means the magnitude of u. So in this case, be -4 squared plus 3 squared, the square root, using the Pythagorean theorem, which is 5. Now you'll also see vectors in 3-dimensional space. The same rule applies if this had another number here, 2, you just add plus 2 squared there. Now, what you're going to run into, as you can probably imagine, is we're going to be doing calculus with these vectors. So for the derivative of a vector, for most of these problems, you just want to treat it like a parametric function. So what that means is think about the vector as a function of t and y here for our horizontal and horizontal and vertical, and you're just going to treat it the same as we've done before where they are separate. So the position of a particle moving in the xy plane is given by the vector 4t squared and y of 2t, where y is a twice differentiable function of t. At t equals 1/2, what is the acceleration vector of the particle? So whenever you see acceleration, you can say, oh, that's the second derivative of the position function. And just as true with vectors as it is with any other equations. So you say, oh, well, if the position is here, I just need to take the second derivative. So I'm going to start with the first derivative. So that would be the velocity vector, which is what we'd call it. And you could just take the derivative separately. So I'm going to start with the derivative of 4t to the third, which would be 12t squared. And using the chain rule there, I'm going to say that that is y prime of 2t times the derivative of 2t, which is 2. So that would be the velocity. The acceleration is going to be the second derivative. So here, derivative of the x component first, 12t squared, the derivative is 24t. Using the chain rule again, we get y prime, double prime now, 2t times 2 times 2. It's asking for a of the acceleration at 1/2. So I'm looking for the vector of 24 times 1/2. I'm going to bring the 2's in front as a coefficient. Y prime, double prime of 2 times 1/2 here, which simplifies the acceleration vector as positive 12 and 4y double prime of 2 times 1/2, which is 1. Hence, the correct final answer is D. And it's one of those things where it feels like an odd question. It's mostly that these ideas apply more to physics than they do to calculus, but with that overlap, we're still going to look at acceleration and velocity and position using vectors. Now, the main thing that's different with vectors is speed. So if you remember that speed is the absolute value of velocity. So what that means is that with a speed vector, this is magnitude, not absolute value. So you're going to have to use root, and then in this case, we've got 3 components, so your x squared plus y squared plus z squared, and because it's of the velocity, you take the derivative of each of those parts. So, given the velocity vector of the particle is the vector v of t, which is 2 cosine of t plus 3t, not plus, but 3t and 2 sine t, so it's a 3-dimensional vector. Find the particle's speed and acceleration. Honestly, I think that acceleration is probably going to be a little bit easier since you just have to find the derivative of each of these terms separately. So I'm going to say that the acceleration is equal to negative 2 sine t, 3, and 2 cosine of t. So often it'll be easier to find that. Speed is going to be your most challenging to find. So speed is the magnitude. So we're going to take root and square all of these, again, based on the Pythagorean theorem. So 2 cosine t squared plus 3t squared plus 2 sine t squared. Sorry if you hear thunder in the background. It's the rainy Wednesday from last week. Now here, I'm going to start by squaring everything. I get 4 cosine squared t plus 9t squared plus 4 sine squared. And this is often something that you're going to be able to simplify. And in this case, you'll notice that you've got cosine squared plus sine squared. You can factor out a 4, cosine squared plus sine squared plus 9t squared. And as I would hope you recall, cosine squared plus sine squared is 1. So your velocity ends up being root 4 plus 9t squared. Multiplying by 1 just leaves the 4 by itself. So again, the last type of problem you could see based on vectors is here we've got a particle moving on the xy plane, has a velocity vector, given v of t is e to the sine t 5t squared for time greater than or equal to 0. What is the magnitude of the displacement of the particle between t equals 1 and t equals 2? So this is the last type. As you can imagine, we take the derivatives with our vectors. When you're given the velocity and it asks for displacement, that means that you're going to integrate. So just like we've been doing derivatives up till now, you can also integrate the velocity vector. And since it's asking for displacement between 1 and 2, we can say that. So what I'm going to start with is I'm going to integrate each part separately from 1 to 2. And I'm going to tell you right now that this is a calculator problem from the AP because you cannot integrate e to the sine t with any form of speed. So use your calculator here, and you should, as long as you're in radians, get 2.605. And since you have your calculator out, might as well do it for 5t squared from 1 to 2 as well, which is 35 thirds. Now it's asking for the displacement. So what this means is that if this is our vector, our horizontal component is 2.605 and our vertical component is 35 over 3, meaning that our displacement between these 2 points is going to be equal to our magnitude. So we actually want to find the magnitude here to give us the displacement. So we're going to say our magnitude is 2.605 squared plus 35 over 3 squared, all under the square root. And since, again, you already have your calculator out, you end up with 11.954, meaning that B is your correct final answer. So now you've seen your vector problems. Looking at these two problem sets, I would like you to split your time between them. How you decide to divide that up is up to you. I will tell you this. 12.2 is review of vectors. Do you remember how to find their magnitude? Do you remember how to add them? Do you remember how to multiply with them? I've attached a video from a pre-calculus class if you want more review than that. And then 13.4 is going to be more of the work with the actual calculus. So I strongly recommend you spend a good amount of time here, but do review as you individually see needed. You will have a presentation problem from chapter 12. If you have questions about anything going into spring break, please let me know and enjoy your time off.